Welcome students. In today's lecture, we are going to learn the concept of cloud computing as well as the role of SDN and network function virtualization in the provision of services related to the cloud. The objective for this lecture are that at the end of this lecture, you would be able to present an overview of the cloud computing paradigm. You will also be able to list and define the principles of cloud services, as well as to define different deployment models of the cloud computing. After that, you would also learn two different architectures, reference architecture, which are used for the cloud computing, and they are NIST architecture and the another one defined by ITUT. So these two architectures we will study in details. And finally, we will see that what is the relevance of SDN and NFV to the cloud computing model. First, let us define what is a cloud computing. However, to understand that, we need to go into the historical perspective of different models related to computing. At the top, you can see that we have the mainframe computer, where users actually communicate with the computer by using a terminal. After that, the concept of PC computing was at the boom, where users were able to directly communicate with their personal computers. And then after some time, the era of computer networks, where different computers were able to communicate with one another, or you can say different computers were connected with one another for the purpose of resource sharing. And then internet computing is like now you can access the different services, the different servers from anywhere, like remote login or accessing a server by using an internet as a backbone. And then grid computing, and finally we come to the cloud computing. So what is actually a cloud computing? The cloud computing is like if we try to define it from the word cloud itself, then the C actually stands for common, L stands for location, O represent online, U represent utility, and D is something which is available on demand. So any computing which fulfill these qualities is the cloud computing. Like it enables computing tasks and information to be available anytime, anywhere, from any device. To define cloud computing, we have to follow the NIST definition, which is like the perfect definition to define the cloud computing. And it says like a model for enabling ubiquitous computing for convenient and on-demand network access in order to share a pool of configurable computing resources, and those resources could be software resources and could be hardware resources like network, servers, computers, hard drive, or maybe it could be software resources like applications, different services running on different computers. And beside those services, those resources must be provisioned and released based on the need very quickly with minimum management effort or service provider interaction. So the basic concept of cloud computing is like we have to access the resources by using the internet anywhere, from anywhere, and those resources must be available anytime with convenient, and it must be accessible from any device, from any platform. So in this regard, you can say that cloud computing would pave the ways for for the provision of many different type of services over the internet. And in many organizations, they have already moved a potential a portion of their IT operations to the cloud. Okay, so cloud computing actually is playing a crucial role in today's IT world. Here is a brief overview that is relevant to the NIST definition. And here you can see that we have 5 essential characteristics. Those characteristics are broad network access, elasticity, measured services on demand, and resource pooling. And if you give attention, this is like exactly the same thing that we saw in the definition of the cloud computing. But beside, we do have 3 types of service models: software as a service, platform as a service, and infrastructure as a service. And finally, we do have some deployment models like private, public, hybrid, and community. We will explore all these elements one by one in details. So basically, cloud computing actually provides, uh, you can say, economy of scale and also professional network management and security management. And these features can be attractive to companies ranging from large to small size, for government agencies, and maybe for individual users who are using PCs or mobile devices. So that is also important for them. These essential characteristics, we have already defined them at the start of this course, but to rewind the concept, I will briefly give an overview here again. First thing is broadband network access, or broad network access. Actually, it is the capabilities on the cloud computing. They are available over the network, and they are accessed through standard mechanism, like from different platforms you can access them. Maybe you are accessing the cloud services from mobile phones, from laptop, from personal digital assistant PDAs, or any traditional or emerging devices like different gadgets, IoT devices, etc. However, they must be able to access by using broadband capabilities like over the internet. So cloud computing actually enables you to expand and reduce. That is the second characteristic, which is related with the rapid elasticity, that it will allow you to expand or either reduce the resources according to your specific need, according to your specific requirements. For example, you may need a large number of server resources for a specific duration of time or for a specific task. Then you can acquire additional resources. And when you do not, require those resources, you can easily release those resources upon completion of the task. The third essential characteristic is measured services, and it means that the cloud system automatically control and optimize resource usage by leveraging a metering capability. For example, how much storage is required, how many processing bandwidth is required, what is the active number of user accounts, how many CPUs will be required. So everything is pay per used basis. Resource usage can be monitored, can be controlled, and reported, providing transparency for both the provider as well as for the consumer. So every service that is available on the cloud is measured on a pay per used based model. And then another characteristic is on demand self service, and it means that a consumer can provision computing capabilities like server time, network storage, is needed automatically without requiring human interaction with each service provider. It's like ease of use. Whenever a demand is required, you can automatically, whenever resource is required, you can automatically demand for it. Okay, and that is going to be like automatic without any involvement of the management activities. So because of this service on demand, the resources are not permanent parts of your IT infrastructure, and you can save a huge amount of money and manpower in this way. And then finally, the essential characteristic is resource pooling, and it is something related with multi-tenant model. Like the resources are pooled to serve multiple consumers at the same time. Although the physical machine could be same, but virtual resources could be shared among different users dynamically. And there is the capability that they can assign and reassign these machines, these resources to customer on demand. A point related to resource pooling is that the degree of location, actually it is independent in that the customer generally has no control, or you can say no knowledge over the exact location of the provided resources, but may be able to specify location at a higher level of abstraction. For example, a country, a state, or a data center where they want to store their resources. Okay, so these were some essential characteristics, and we do have some services models, which are also sometimes known as cloud services. And the three of them are software as a service, platform, and infrastructure as a service, and they are mentioned here. So let us define these models one by one. The first model is software as a service. Actually, the software is a service. It provides services to customer in the form of softwares, or you can say application software running on and accessible in the cloud. Sometimes it is also known as application as a service. With this basic model, the end user pays a subscription fee on a per use basis for on-demand software system. Sometimes these resources are freely available. Okay, so the service provider actually maintains the infrastructure, the operating system, and the software, while the end user simply runs the application remotely. Here you can see the infrastructure, which is an important part, is visible only to the provider. The cloud platform, the different operating systems of system softwares, they are also visible only to the provider. And on the top we have the application softwares. They are provided by the cloud, but they are only visible to the subscriber. Not subscriber has no control over the software. They can only use them in this model. Okay, so here you can say that the customer has a very little control over over this model. They can only use the applications provided by the service providers. So the customer does not manage or control the underlying cloud infrastructure or servers, operating system, storage, or even individual application capabilities. They have no control in this model. So this has the potential to reduce corporate IT operating cost by outsourcing the maintenance of hardware and software to the software as a service provider. And some common example of SaaS provider is like the Microsoft Office 365 that is available to the end user over the internet. And another example is the Google applications that we are using. And very common example is the Gmail that we are using free of cost. Similarly, another example is Salesforce.com. All these are example of software as a service that enable customers to use the cloud provider's application running on the provider's cloud infrastructure. And these applications are actually accessible from various client devices with the help of a very simple to use interface. And sometimes they are accessible by using the web browser. For example, you can access many of the Google apps by using your web browser instead of obtaining desktop and server licenses for software products that you require. So this is the best solution, not only for individuals but also for organizations. And then the second model is known as the platform as a service. And this model actually provides service to customer in the form of a platform on which the customer applications can run. There is the difference. Now you can run your own application on the cloud with the help of this model. And it enables the customer to deploy onto the cloud infrastructure customer related or acquired application. And it provides a useful software building block here in the form of the platform that is provided to the customer, and many other tools that will assist in deploying new applications. So actually the platform as a service, the cloud platform that is available in this case to the customer is like an operating system in the cloud, and then you can install different software on top of that. Okay, so in the platform as a service model, developers essentially rent everything they need to build an application, and they have to rely on a cloud provider for deployment tools, infrastructure, and operating system. Okay, so actually in this model, what is offered to the developer, to the customer, is like a developmental tools that are available to the customer, different middlewares, operating system, maybe database management system, and the infrastructure itself. So in this model, the consumer does not manage or control the underlying infrastructure network, like the servers, operating system, or storage, but they do have control over the deployed applications and possibly application hosting environment configuration as well. And some of the example of the platform as a service provider include Microsoft Azure, cloud services, Google App Engine, and a variety of web hosting companies which are offering their platform as a service to the consumer. For example, Google Compute Engine is another example, Rackspace, Amazon EC2, and things like that. All these are examples of the some of them are the examples of the platform as a service. And another examples are, as I just mentioned, are App Engine, Engine Yard, Microsoft Azure, Force.com, etc. And then finally, we have the infrastructure as a service. And here you can see that in the platform as a service, the infrastructure again is visible only to the provider. But the difference here is that the cloud platform is now visible to the subscriber. In the software as a service, that was visible only to the provider, but here it is visible to the subscriber as well. And then the third category, the cloud infrastructure, is also visible to the provider. Now you can see here we have a very little control. Here we have like a moderate control, and here we have like more control, because the infrastructure is also available and visible to the subscriber, beside from the platform and beside from the applications. So here you can develop your own application, here you can have your own platform, and here you can have your own physical resources in the form of virtualized form, in the virtualized form, like different servers, different storage devices dedicated to your work, and things like that. So infrastructure as a service, actually the customer has access to the resources of the underlying cloud infrastructure. It provides virtual machines and other abstracted hardware and operating system. So typically customers are able to self-provision this infrastructure by using a web-based graphical user interface. And examples here are Amazon Elastic Compute Cloud, Microsoft Windows Azure, and Google Compute Engine, beside from Rackspace. And here, this service provider typically leases out the data center elements, the building block of the data centers, including the server, storage, and networking capabilities. So the consumer does not manage or control the underlying cloud infrastructure, but has control over the infrastructure, over the operating system, and things like that. So this will allow the client to build their own virtual data center within the service provider facilities. Okay. Now let's come to the third element, and that is the deployment models. This is another way to look at the cloud services. In a traditional environment, you do have control. The client do have control. The customer do have control on everything, like the applications, the middleware, the operating system, the server, the storage, the networking. While in case of software as a service, you have no control on anything. In a platform as a service, you have a little control, and there is the platform and the applications. You can install different applications on different platforms. And then in the infrastructure as a service, you have a high level of control. Okay, you can develop your own application, you can store your own data on them, you can run them, you have control over middleware, over the operating system, you can install your own operating system. But beneath them, you have no control over the core element. They are still under the control of the service provider. Now some other services. Actually, we studied three types of service models: software as a service, platform as a service, and infrastructure. But with the passage of time, other services are being added to the list. For example, we do have a new service that is known as communication as a service. And that is like for real-time interaction applications like video teleconferencing, web conferencing, maybe instant messaging, voice over IP, things like that. So now it means that you can almost offer anything as a service in the cloud. Like you can see, we can offer computer or compute as a service, which is like the provision and use of processing resources needed to deploy and run softwares. You can offer data storage as a service, like the data, you can use the data storage capabilities in the cloud. So client leases storage spaces, only storage spaces from third-party providers, like you are using the Microsoft storage, or you can use, for example, the Dropbox facility. That is like a data storage that is offered to the user, sometimes free of cost, sometimes you have to pay for them. So data is transferred from the client and servers, a service provider by the internet, and the client then accesses the stored data using software provided by the storage provider from anywhere, anytime, by using the internet facility. We also have database as a service, where it provides the ability to leverage the services of a remotely hosted database and sharing it with other users and having it logically function as if the database is operated on a local machine. We also have desktop as a service, where data, uh, the ability to build, to configure, to manage, to store, to execute, and to deliver user desktop functions remotely over the internet. And that is important for offloading common database application and also data from user desktop or laptop computer into the cloud. We can also offer email as a service. We can offer identity as a service, even security as a service, and other things. Trust as a service, for example, and things like that. So the list is continuously growing. So that is why there is a common terminology which is known as X as a service, where X can represent any possible cloud service option. X can be anything. X can be everything, or X can be X. Okay. So these are other services that are now provisioned by using the cloud computing. Now, the third component is the deployment models. And here we are going to study 4 different types of deployment models. They are the public, private, hybrid, and community. First, let us see what is a public cloud. So the public cloud is actually an infrastructure that is made available to the general public, or you can say a large industry group, and that is owned by an organization who is actually involved in selling cloud services. The cloud provider here is responsible both for the cloud infrastructure and for the control of the data and operations within the cloud. A public cloud may be owned and managed and operated by a business entity, sometime maybe an academia, or sometime a government organization, or sometime a combination of them. Okay, so it exists on the premises of the cloud service provider. This is a normal model that we are using very much in day-to-day life. In this public cloud model, all the major components are outside the enterprise firewall that is located in a multi-tenant infrastructure. What does it mean? It means that applications and storage are made available over the internet by using a secured IP and TCP channel, and that can be free or may be offered as a pay-per-use basis. The two key players here are the Amazon Cloud Services and the Google On-Demand Web Applications. And other examples are like Yahoo, Mail, Facebook, LinkedIn, social media. They're providing free storage for your photographs and other stuff. Although these public clouds are inexpensive and they can scale to meet the needs of the organization, they typically provide no or very low service level agreement, and they may not offer the guarantee against data loss or corruption found with other types of offering like the private or hybrid or community models. So the public cloud, the infrastructure is a service, do not necessarily provide for restrictions and compliance with privacy laws, which remain the responsibility of the subscriber or the corporate end user. So the major advantage of public cloud is the cost. It has a very little cost because you do not need to have your own data structure. You do not need to have your own infrastructure, your own manpower, your own electricity, your own cooling system. A subscribing organization pay only for the services and resources it need and can adjust these on need basis. Okay. So public cloud, the infrastructure is made available to the general public or a large industry group or organization, but this is owned by an organization who is actually selling the cloud services. And the cloud infrastructure here is provided for open use by the general public, and it may be owned, managed, and operated by businesses, by academic, by government organizations, or maybe a combination of them. Then we have the second type, which is known as the private cloud. And private cloud, the cloud infrastructure is provisioned for exclusive use by a single organization. Here you can see we have multiple organizations, even individuals. Here we do have only a single organization who is using this cloud services. It may be owned, managed, and operated by the organization or sometime a third party, or maybe a combination of both of them. Large corporations, they may prefer to choose and build a private cloud data center, which can be administered either internally or through an outside service, and may be hosted internally or at an external location. So both the options are possible. So actually a private cloud is implemented within the internal IT environment of the organization, and the organization may choose to manage the cloud inside their own organization or maybe outside that organization. So private clouds can deliver information infrastructure as a service internally to employees or the business units through an intranet or the internet. If you are using internet, then you have to use the VPN, virtual private network. Okay. So a key motivation for this option is enhanced security. A private cloud infrastructure offers tighter control over the geographical location, which is an issue with the public cloud. You have no control over the location of the data, or you have very little control over the location of the data. But here you do have enhanced security and more control over the data. Then we have another type which is known as the community cloud, and a community cloud shares characteristics of private cloud and public cloud. Like a private cloud, a community cloud has restricted access, like more than one organizations, but they too have common interest. It's not a public, it's a community. Okay, so it has the feature of private cloud, and like the public cloud, the cloud resources are still shared among a number of independent organizations, not users. The organizations that share the community cloud must have similar requirements or must have similar characteristics, and typically a need, sometimes they have a need to exchange data with each other. And one example of such industry or such organization who is actually using the community cloud is the healthcare industry. So the community cloud, the cloud infrastructure is provisioned for exclusive use by a specific community of consumer from organizations that have shared concern or that have common interest. And then finally, we have the hybrid cloud. As you can see, it is like the composition of two or more clouds. It could be a composition of a public and private cloud, or a public and community cloud, or private community cloud, or maybe a combination of the three. Okay, so that is like it will combine the best feature of all the three. Not only the best features, sometimes they will inherit the disadvantages of these approaches. So a hybrid, for example, a hybrid public and private cloud solution can be particularly attractive for smaller businesses. Many applications for which security concerns are less can be offloaded at a considerable cost by using the public cloud. And other things, sensitive data and applications will remain in the private setup. So the cloud infrastructure here is a composition of two or more clouds. And in many cases, corporation can keep the sensitive data in their local data centers and less critical data to the public cloud. If we compare the characteristics here, this table gives a summary of all the models. You can see this is quite simple to follow, so you may follow it by your own. Okay, next let's see the models, the cloud architecture models. As I mentioned, we have two models available for the cloud. They are for reference purposes. You can choose any one of them. The first model is the NIST Cloud Computing Reference Architecture model, and it was proposed in 2011. And this actually focuses on the requirements of what cloud services provide, not on how to design solutions and implementation. Okay, so it focuses on the what portion. Like it will describe the tools and the tools that are required for developing a system specific architecture by using a common framework of reference. Actually, this model was developed by keeping in mind certain objectives, like it will illustrate and understand and will allow us to understand the various cloud services. You can see it has a portion for services or more than one. And then it will provide a technical reference for consumers to understand, to discuss, to categorize and compare cloud services. And also it will facilitate the analysis of candidate standards for security, interoperability, for privacy and other things. First, let us see the computing actors which are involved in this architecture. Well, here you can see that it actually defines 5 major actors, and they have different roles and they have different responsibilities. What are those actors? The first actor is the consumer. The second actor is the provider. The third actor is the auditor. The fourth one is the broker. And the fifth one is the carrier. These are the actors who have different responsibilities in this architecture. The cloud, first let me discuss the cloud consumer, starting from 1. Actually, it could be a person, an individual, or an organization that maintains a business relationship with the provider, or who is actually using the services provided by this cloud provider. The provider, the second element, the second role player here, the provider, it is like an organization or an entity who is responsible for making a service available to this consumer. And the auditor, as the name indicates, is a party, is an entity that can conduct assessment of the offered services independent from the provider point of view and independent from the consumer. He will not favor any one of them. He will do an independent assessment of the services provided. Okay, and these services could be the operations, could be performance, could be security, could be privacy, could be trust, could be the availability and other stuff. And then we have the broker part, which is an entity that manages the use, the performance, and the delivery of the cloud services, and will negotiate relationship between the cloud provider and the consumer. It's like a third party who is paying the road between these, the provider and the consumer. And finally, we have the carrier, is an intermediary that provide connectivity and transport of cloud services from cloud provider to the consumer. So if you see, the whole setup is for the consumer. Provider will provide the services, auditor will assess the services, broker will pave the ways between these two, and carrier on the other side will provide the connectivity for the services. Okay, so the important thing here is the provider. So let's start from the provider, or let's elaborate the provider portion more here. The cloud provider can actually provide one or more of the cloud services to meet the IT and business requirement of these consumers. And you can see the services are offered by using the different model that we just studied. Okay, and then we have the carrier. The carrier here is a networking facility that provides connectivity and transport of cloud services between the consumer and the provider. And typically, a cloud provider will set up different SLAs with the cloud carriers to provide services consistent with the level of SLAs offered to the consumer. And then the broker is useful when the cloud services are too complex for a cloud consumer to easily manage. So he will take the services of the broker. And the areas in which the broker will offer their services is the intermediation, aggregation, and arbitrage. Intermediation, these are like value-added services. Like if you require identity management service, then you can consult this broker. If you want performance related metrics, if you want to enhance your security, then you can ask this broker. Intermediation, any service that is not offered at the time by the cloud provider, you can ask the broker. And the auditor, sorry, the next one is the aggregation. The broker actually combines multiple cloud services to meet the consumer need, not specifically addressed by a single cloud provider. Maybe he has linkages with other cloud providers, so he can manage to optimize the performance or to minimize the cost. He can actually manage other services from other service providers. And then arbitrage. This is similar in concept with the aggregation, except that the services being aggregated, they are not fixed. Services arbitrage means a broker has the flexibility to choose services from multiple agencies. Like the cloud broker, for example, can use a credit scoring service to measure and select an agency with the best score, and security services from another service cloud service provider, and things like that. On the other side, the role of auditor is to evaluate the services provided by a cloud provider. Different matrices are available. He can measure the performance in terms of security control, in terms of privacy, in terms of performance like availability, reliability, things like that. So the auditor is like an independent entity that can assure that the cloud provider conforms to a set of standard. To have further idea, we do have an interactions between these two, which we will discuss later. First, let us see what is inside the cloud providers. So here you can see the orchestration. Actually, this inside this cloud provider, you can see 4 main architectural component. One of them is service orchestration, which refers to the composition of system component that are essential to support the cloud provider activities in arrangement, coordination, and management of computing resources. So orchestration is shown here as a 3-layer architecture. Okay. So the familiar mapping of physical resources to consumer visible services by a resource abstraction layer. Okay, so that is important. Examples of resource abstraction component, it will include software elements like hypervisor, virtual machines, virtual data storage, and other computing resources abstraction. Then the cloud service, the second one, the cloud service management. It will include all the service related functions that are necessary for the management and operation of those services required by our proposed to cloud consumer. And it itself covers 3 sub areas like the business support, business related services dealing with customers, provision and configuration, which will include tools for rapid deployment of cloud system for consumer, and then portability and interoperability. Consumers are sometimes interested in cloud offering that support data and system portability and service interoperability, and this is particularly useful in the hybrid cloud environment. And then we also have the security and privacy, which is parallel here, and they are concern that encompasses all the layers and all the elements of the cloud provider's architecture. Now let us see how these role players, these actors interact with one another. So you can see here we have a very simple illustration between the interaction between the actors. We have a cloud consumer here, like on the top left side you can see a consumer, and this consumer may request different cloud services which are offered by a cloud provider. The consumer can either directly access these services by using the cloud carrier, by using the internet facility, or the consumer may request a broker to access the services indirectly. And then we do have a cloud auditor here who actually conducts independent audit and may contact both the entities, like he can contact the consumer as well as the producers to collect necessary information. So this was the first architecture. Our next architecture is proposed by ITU, and it was proposed in 2014. And the number of this architecture is ITUT Y.3502. And it is also a layered architecture, a layered functional architecture. And instead of 5 cloud computing actors, here we have only 3 actors. And those actors are cloud service user, which is also known as cloud service customer, and we have the cloud service provider, and we have the cloud service partner, which is like the broker in the previous case. So the differences between these two architecture is the layered and the number of players. So cloud service user actually is the user, as we just saw in the previous approach, who is actually using the cloud services and who is actually performing business administration and administration of the services that the company is actually acquiring from the provider. And then we have the service provider, who actually the organization who will make the cloud services available, and they focuses on activities that are necessary to provide cloud services and activity necessary to ensure it deliveries to the customer, as well as to their maintenance. They are also responsible for it. And then we have the third role player, who is the partner, cloud service partner, a party which is engaged in supporting or maybe helping out activities of either the cloud service provider or maybe the cloud service customer, or maybe the both. And some examples of the cloud service partners are auditors and the brokers. So here we combine the 3 entities into one entity. Okay. In the previous architecture, they were different. The broker, the auditor, and the carrier, they were the broker and the auditor, they were different entities, but here we have combined them into a single entity. And in this figure you can see the interactions between these 3 players. On the bottom it shows the customers, the consumers, the users, like we have more than one users here. And then we have the providers, and you can see the providers can also communicate with one another. Okay, like we have horizontal communication, we have vertical communications, and different providers are possible, like provider number 1, provider number 2, and this is provider number 3, by the way. Okay, and you also see that some provider actually offer services like software as a service, platform as a service, infrastructure as a service, communication as a service, network as a service, and so on. While other providers will only facilitate the communication between different providers. And then on top, we have the partners, the brokers, the auditors, and they are actually communicating with these providers. Okay, so this is the architecture which is proposed by the ITU. And let's see it from another angle, the same architecture from another angle. As we just said that it is a layered architecture and it is made from 4 layers, as you can see them here. This reference architecture has 4 layers. On top we have the user layer, and it is where the user interface is provided through which a cloud service consumer or customer interact with the cloud services. Okay. And we have the access layer, and this access layer provide a common interface to the capabilities available in the service layer below it. These capabilities include both the capabilities of the services as well as the administration and business capabilities. So the access layer is actually responsible for presenting these cloud service capabilities over one or more access mechanism. For example, by using a set of web pages accessed by using a browser. So the access layer also deals with other aspects like security, privacy, and quality of service. Then the third layer is the service layer, and the service layer contains the implementation of these services, of the services provided by the cloud service provider. And these services, as we know, they could be like a software as a service, platform as a service, infrastructure as a service. So the service layer contains and control the software components that actually implement those services. And then at the bottom, we have the resource layer, and the resource layer consists of physical resources that are available to the provider and to the appropriate abstraction and control mechanism. For example, hypervisor software can provide virtual network, virtual storage, virtual machine capabilities. So this multi-layer functions, it include a series of functional components that actually interact with the functional components. On the right hand side, we have a huge number of functions, and that are represented by the multi-layer functions. And if you give attention, we have 5 different or 5 sub elements here, and they do have sub elements again. For us, the important is the left hand side, because we are going to link it with the SDN and with the NFV. But to give you an overview, here we have an integration subcomponent which is responsible for connecting the functional components in the architecture. And how it is possible? It is possible by providing message routing and message exchange mechanism with the cloud architecture and with these functional elements. We do have security systems element, and security related functions are handled here, like authorization, identity management, encryption, privacy, stuff like that. So security systems is responsible for applying security related controls to mitigate the security threats in the cloud computing environment. And we have the third one, which is the operational support system, and it is actually a set of operational related management capabilities that are required to manage and control the cloud services offered to the customer. We also have a business support system, that is a set of business related management capabilities which deal with the customer and supporting processes like billing information, like dealing with accounts management, subscription fee, and things like that. And finally, we have the development function, which support the cloud computing activities of the cloud service developer. This will include support for development of services, their implementation, building management, and test management, etc. So this is the ITU cloud architecture. Next, we are going to see how SDN and NFV are helpful for this specific cloud architecture. Cloud computing, we know it exists before the software-defined network and before the network function virtualization. So it means that cloud computing can be used and it is in use without the deployment of SDN and NFV. So you can say both of these technologies are not part of the cloud computing, but they can support the cloud computing infrastructure. They can reshape the current infrastructure of the cloud. Both these technologies are compelling for both the private cloud operators and as well as for the public cloud service providers. Now, what SDN offers? So SDN for the cloud computing, it will offer a centralized command and control of network resources and traffic patterns. We know in the SDN we have a boss, that is the central controller, or in some cases more than one controller in a distributed form, but they are cooperating with one another. So this controller or this controller can configure and manage the virtual networks, and they can provide different quality of service and also security services. What NFV can offer? NFV offering is automated provisioning of the devices. NFV virtualizes network devices. That is the basic concept of NFV. What are those devices? Those devices could be your switches, could be your routers, could be your access point, could be the hardware firewalls. It could be computing devices, it could be storage devices, and things like that. So NFV will provide tools for scaling out and automatically deploying devices as needed. Therefore, each project or cloud customer does not require separate equipment or reprogramming of existing equipment. Why? Because the relevant devices can be centrally deployed with the help of a hypervisor management platform, and they can be configured with rules and policies, and everything controlled from a centralized entity. Now let us see the service provider perspective of this approach. A large cloud service provider will deal with thousands of customers or maybe millions of customers, and their needs are going to be dynamic. Their need for the capacity, both in terms of traffic carrying capacity and in terms of computing and storage resources capacity, they are going to be different. So they need to deal with such a dynamic diversity of the customers. The providers need to be able to rapidly manage the entire network to handle traffic bottlenecks that may appear. They may need to manage numerous traffic flows having different quality of service requirement, and they also need to deal with the outages and other related problems. All of this must be done in a secure way as well. So SDN can provide the needed overall view of the entire network and secure centralized management of the network. So the providers need to be able to deploy and scale in and scale out, up and down virtual switches, virtual resources, virtual servers, storages rapidly and transparently for the customer. So there is the need that can be fulfilled from the service provider point of view. If we consider the private cloud perspective, so that is also possible. As we know that many large size and some medium size enterprises, they see a number of advantages to move their network based operation to a private cloud or sometime a hybrid cloud. The enterprise typically will need to develop one or more server or maybe data centers. As the overall resource demand grows, the ability to deploy and manage all of the equipment become more challenging for them. In addition, there are going to be security requirements which need to be fulfilled, like installation of firewalls, deployment of antivirus software. So as the need of the rapid capability increases and the provision of devices become more and more pronounced, the need for automated provision of virtual networking equipment almost become a requirement. And with all the new virtual devices, centralized command and control become a necessity. So SDN and NFV provide the enterprises with the tools to successfully deploy and manage and control the private cloud resources for internal usage. Now let's see this architecture. Actually, it shows the same 4-layered architecture that we saw here. The left hand side, user access service resource, user access service resource. But here, the last layer has been modified. This architecture has the same 4 layers as we saw in the previous I2 architecture, but it provides more details of the lower layer. Now here, the lower layer is called resource and network layer. And this layer itself consists of 3 sub-layers, as you can see here. What are these layers? The first sub-layer is the resource or orchestration. And here the management, the monitoring, the scheduling of the computing of the storage and network resources into consumable services by the upper layers and by the users. They are responsible for these services. The management and monitoring of all the computing resources by the users. Then we have the pooling and virtualization. And virtualization is a must. Why? Because the virtualization function turns the physical resources into virtual machines, virtual storage, virtual networks. So these virtual resources are in turn managed and controlled by the resource orchestration. And they are controlled, they are allocated and reallocated based on the user demand. And then we have the physical resources, like the actual computing, storage, and network resources that are fundamental to provide cloud services. These resources may include those that reside inside cloud data center, for example, the computing servers, the storage, and things like that. And also those devices that resides outside the data center, typically networking resources like the inter-cloud network, as you can see here, and the core transport networks. So the resources and network layer can be implemented by using the network function virtualization. Okay, so we have studied how SDN and NFV will facilitate the cloud computing implementation. Both NFV and SDN contribute to the deployment of cloud services. Thank you so much for attending the lecture. Take care and goodbye.